So today we are going to start our new unit, which is graphical models. So it's basically what we did before is algebraic models. So we're solving equations using algebra. Today we're going to start with graphical. So we're going to be graphing to solve. Okay. The things that I just want to remind you of that we're going to be using Excel. So if you don't have Excel at home on your computer, you probably want to download it. And I taught you how to download it at the beginning of the semester. Remember, you have to go to the portal, you have to log in, press on the 360 on that orange icon, the 360 or 365 or whatever it is. 365, and then you have to download Microsoft.
I'm trying to do it. He told me how to pay. It's not free.
It is free.
It should be free.
Did you go through the school website?
Yes, I told you He told me now I have to pay. When I try to download it, it comes a window that told me it's the process. I don't remember something.
Do you have your laptop?
Yes.
Is it on laptop?
Yes.
Bring the laptop with you to school tomorrow.
Okay.
Yeah. Because it is, I've done it at home.
And on this line, no.
Does it work on an iPad?
Yeah.
I've never tried on a tablet.
We can try,
Yeah.
but we'll try. We can
I
try.
don't see why would it, because I could put it on any device.
Yeah.
And I don't have a limit. So I can put it on every computer in my home.
Yeah, I tried. I don't know what.
I think there is a limit of 10.
Yeah, sure. Sarah was
Okay.
with me. I showed her the window that I have to pay.
You can
Bring the
see-
laptop. Maybe we can do it here.
Okay.
Okay.
That is a lot, though.
Yeah, that's a little. So anyway, because you're gonna need Excel for the next chapter, okay? Your homework will require graphic technology, and you need Excel. So if you don't have Excel, you wanna download it, okay? And that's the reason why we are moving to 103 as of tomorrow, okay? We're gonna move to room 103, which is the computer lab, the Mac lab, where there's all the Macs. This is where we're gonna go. If you have a USB key, bring it with you. Okay, so you can save stuff on it. Well, again, you don't need a USB key because you have the OneDrive. You can always save on the OneDrive. Look in the first floor.
I hope you
Yeah.
didn't get deterred from this.
Okay. So let's start with the lesson. So today we're gonna discuss trends in graph. So a graph is a visual representation, right? So it's something that you can see, you can visualize of the relationship between two quantities. So if you think about an equation, right? You look at an equation, y equals 2x squared plus 3x plus 5. You look at it, you're not going to see what's going on. But when you look at the graph, you're going to see what's happening. When is it decreasing? When is it increasing? When do I have the min? When do I have the max? How does it look like? Okay? But it's always your graph is a visual representation of two variables, the relationship between two variables. Something on the x, something on the y. We always have something that is dependent on something else. So we have a dependent and we have an independent. Okay? Where do we put our independent? What axis? On the x-axis. Okay? So the independent variable goes on the x. And your dependent goes on the y. So it shows, the graph shows how one quantity changes with respect to the other quantity. Okay? So is it decreasing? When one is decreasing, is the other one increasing? Is the one, like, this is what the graph shows. We're going to look at the different types of graph, and then we're going to describe the relationship shown in the graphs. We're going to look at, describe the trend for it. What do you see? Jack's babysitting graph. So what am I comparing? What are the two quantities that I'm comparing?
There's two ways to
hour of work and earning.
That's right. Hour of works and then how much money he made,
Yeah.
right? Now, describe the graph for me, describe the relationship for me.
More hours the person works, more money he gets.
That's right, right? It's an increasing, right? You see that the graph is increasing, right? Which means the more money, the more hours that person works, the more money he makes. But we also see that my rise is constant, right? It's always gonna increase by the same amount. Okay? So let's say if that person get paid $15 an hour, second hour he's gonna pay 30, third he's gonna be paid 45. So it's the same $15 per hour every time. So So what kind of relationship is this? If you look at the graph, what can you tell me about the graph? Describe that graph for me. It's going up. How is it like a squiggly line?
No,
Is
it
that-
is,
it's linear. Linear, right? It's a straight line, right? It's a straight line. Now, the second question is we're looking at the amount of compound interest investment. Do you guys know what a compound interest is? Michael? You can have it more than one time a year, yeah?
The money that I get if I invest some money, the capital of money. For example, I have X money. I invest it in with the action, in market, and the money that I will get from this money.
So the interest, but
Interest,
there's a
yeah.
specific way. There's simple interest where you get the same amount of interest every year, or you have the compound interest. The compound interest is a bit different because so let's say after a month you earn this much interest. Let's say you earn $10 of interest. The next month you earn interest not only on what you put in, not only on your principal, but also on your interest. So you're accumulating more interest as you go. You're accumulating more money because you're earning interest on the interest.
Okay, not only on the capital, but the capital plus interest.
Plus the interest.
I said the capital too.
We call it principal.
Yes.
Yeah, but yeah, I know what you exactly what you mean.
I know.
Now, if you're looking at this, so amount of compound interest invested. Okay? So what are my two variables? What are my two things that I'm comparing? Excuse me. That's right. So the time, so how long it takes, and then the amount, which is how much money you have on your bank account. What can you tell me about the relationship between the two? It is not linear. It's increasing. Okay, so the amount is increasing as time is increasing. Sorry, what did you say? Equal ratio? So it's not equal ratio, right? At the beginning, you have a very slow increase, but then at the end, you have a fast increase or a large increase, okay? We call this an exponential increase, okay? This is what an exponential increase would look like, where you're starting slow, and then you're growing faster and faster, okay? Exponential. So let's write the, so the amount of compound, that's a compound, I apologize for my writing, interest, increases over time. Slowly at first, and then very fast. Okay, now as you can see, I have copied the same graph over here. That is wrong, because by mistake I pasted the same graph. So let's ignore this one. And this is how your graph should look. If you look at your rise over run or your ratio, or how is it increasing or decreasing, what can you tell me? What do you have first, a larger increase or a smaller increase? At the beginning. At the beginning it's a larger decrease, right? Not increase. And then kind of a very small decrease, right? What can you tell me about the two variables? So what am I comparing? Temperature and time. So temperature of a cooling cup of coffee. So you put your coffee, you buy your coffee in the morning, or you make your coffee in the morning. It's boiling hot. You can't drink it. You put it in the room temperature. What's gonna happen to your coffee? The temperature is gonna go down. Now, if I buy my coffee, right? The first few, maybe the first like 10-15 minutes, the temperature of the coffee is gonna decrease fast because it's hotter, much hotter than the room temperature. So there's more interchange between the room temperature and the coffee temperature, right? But when my coffee, after 2 hours, my coffee is gonna cool down to room temperature, right? Is my coffee gonna get any colder? No. So I'm gonna see that kind of a settlement in my temperature, right? Where my temperature, my coffee temperature is not gonna change anymore. It's gonna be kind of constant at that point, right? It's already at room temperature. There's nothing, unless I put it in the fridge, it gets cooler. Okay? This one,
Yeah.
larger decrease. And we see a decrease, right? The other one that we have seen is an increase. So the coffee temperature decreases over time, rapidly at first, then more slowly, finally leveling. Leveling all over. Just give me a second, I'll get back to this page. I have to export so I don't lose it.